What is the point of the immune system? We know that we have one, and we know that it has many different components, and we know that it's quite confusing. But do we actually understand why we have one in the first place? What is the necessity for our body and for the bodies of all mammals and birds and reptiles and fish and plants, in some cases, to actually have a working immune system? To be able to understand that, we have to think a little bit bigger and we have to think about some general concepts about life to be able to understand why do we even find ourselves in this need. The first thing we need to think about and we need to be comfortable about is the idea that everything on earth ultimately wants to be able to pass on its genetic material. We can dress it up, we can talk about lots of different things that are interesting about life and how we want to achieve great things, but innately in all of us, all the way down to the smallest organisms around, we want to try and pass on what we have as our own code to the next generation. I'll stop right there and just bring myself back to my introductions. If you haven't met me before, or you don't know who I am, or you're the first time you've come to these talks, my name is Ross, and I'm a consultant immunologist, and I work actively in a diagnostic and investigative laboratory for the National Health Service in the UK. And this channel is designed to be able to go through very, very short questions around the immune system. Please look in the box in the corner to see all the previous talks that you may be interested in, or if you're having trouble working YouTube and you want to have an understanding about how you even subscribe to a channel or like a video or put a comment on a video, there is also a video you can access to be able to do that. Okay, back to where we are. So we're talking about our idea about everything wants to pass on its genetic code. Now, we like to think about how things achieve that, and we think of lots of lovely examples, such as polar bears, who we think of as the extremes of organisms that have had to evolve and adapt to be able to pass on their DNA, but live in a really tough environment in order to do it. And we have other examples that we really like. We really like the idea of camels as well, because they live in hot, dry places and have had to evolve again to live to be able to pass on their DNA. But there are lots of other organisms out there that we perhaps don't think about, we don't get as excited about, and actually they're far more important when it comes to us. And three of them I've highlighted here. We can bring them down loosely into three categories. Number one, bacteria, the biggest group that we know of. And during the talks that we'll go through over the series, I will bring up bacteria constantly. And what you can see here is an excellent graphical design of multiple bacterium, okay, that are there. And you can see their job, and they're highly specialized for what they want to do, which is to ultimately be able to live and pass on their DNA. We have others such as fungi. Okay, fungi can be molds, it can be mushrooms, it can produce spores. There are lots of different types. And the final ones we have are parasites or multicellular parasites, the ones such as worms, tapeworms, or schistosomes or helminths. And these are much more complex animals that again can get inside a mammal's body, travel around, inhabit organs, but ultimately they want to pass on their DNA and create new versions of themselves. So to be able to understand a little bit about why is it necessary to interact with us as bigger organisms for them to be able to pass on their DNA, we have to go back to some basic physics and some ideas around energy transfer. Because to be able to pass on your DNA, you have to have quite a lot of energy available to you. We know that smaller human beings eat a phenomenal amount of food because they've got to grow and they grow into very, very big human beings. So to be able to do that, you need energy. And the thing about energy, you can take it as a universal law, and Isaac Newton was a really important person for doing this, is that energy is something that is not created. It is purely transferred around the universe from one form to another form. You also can't destroy energy. Okay, it will just spread out and it will come out in lots of versions. So it might come out in heat, for example, is a great example of how energy can often be dispersed out into the air atmosphere, warming up molecules around it. Now, if you think about that in the terms of passing on your DNA, every living thing needs energy to be able to perform its organic processes. If it doesn't have that energy, it's not going to be able to do those processes, such as replicate. And that, again, is its primary driver. So if you're going to find some energy, you've kind of got two options. One option you've got is to look around you and gather up any energy you can find, or nutrients or food that you can find that exists around you. Great example of that is a vulture. It's scavenger, it's designed to sit there and pick away at carcasses where nothing else is left, because that is where it's going to get its primary energy source from. We could take another example, and we'll take a lion. A lion doesn't bother to really scavenge. Of course, it might do sometimes, but ultimately it's going to seek to just devour the entire composition of another organism to digest and get its energy. So it's going to hunt, it's going to actively go and get that energy from another thing, rather than wait for that thing to be dead or to have the opportunity of that energy just existing in another form. Now, when we talk about microorganisms, what we're really thinking about is that they look at us as a gigantic fridge full of food. We're brilliant. We're stocked up to the max. And so, not only have you got that we ourselves are composed of organic material that can be eaten, a bit like the lion trying to get an antelope, you can eat us physically and get energy from that eating that will allow you to be able to replicate. You've got another option, because we ourselves put food into our system for us to gain energy. And so you've effectively got a giant tube that starts here, ends down below this desk, that has food and energy passing all the way through it. And so, a bit like when you go to some sushi restaurants that will have a conveyor belt where you can just pick the food off, if you situate yourself inside the human body at the right place, then happy days, because you're going to be able to get that energy wherever you want. Now, the biggest area of your body where you're going to see that action is going to be in your bowel, your stomach, and your bowel. So, your small intestine is the most important part of your body, where you yourself absorb the energy from your food. It's where you get all the nutrients, okay, the proteins, the fats, the sugars. You've been digesting them all the way through, and now we're at an absorption phase. And much like that, you expect to find lots and lots and lots of bacteria that are also going to exist there as well. So you have a large intestine and a small intestine, and what happens is that actually within there you're going to have, usually the most common is going to be bacteria. So your immune system starts to come into important role here, because what we're basically saying is that you are going to get overtaken by an army of organisms that are smaller than you but vastly outnumber you, and they're going to eat away at everything you're eating, and they're also going to eat away at you yourself. So if you're not careful, you're going to end up becoming completely devoured and invaded. So you need an immune system to be able to help you with this. It gets a little bit more complicated, because primarily your immune system is designed to think, right, it's not me, so therefore it could be dangerous. We have an extra complexity to that, because not everyone who exists inside us is bad for us. There is a large proportion of the microorganisms that live inside you that are actually good for you, and we call those commensals. And the reality is that they are there to take up space. They take up finite real estate inside that gut to stop other organisms being very bad. So the reality is, although I have two colonies of bacteria, two types of population of bacteria that might live inside my gut, they actually are very different in what they do for me. Some are very good for me, some are not so good for me and could be very harmful. And if we disturb that ratio of how we have those bacteria, then we're going to end up in a problem. So, coming back to what your immune system has to deal with, your immune system, first of all, has to be there to stop your microorganisms that exist on you, inside you, that want to eat all the energy that you yourself are trying to consume. They're not doing it to be malicious. They're not doing it to be horrible. They didn't wake up one day and think, Ross, I'm going to do you today. This is what I'm going to do. It's not what they want to do. It's just business. They just want the energy. They want to make their DNA be passed on to another generation, the same as you do, really. And so your immune system is really there to make sure that you yourself don't lose the opportunity to pass your DNA on. But like I said, it's complex, because ironically, if you get rid of all the bacteria that are there, including the good ones, you can actually end up worse off. How do we know this in real terms? A great example is when we give, as human beings, to other human beings or to animals, antimicrobial drugs, antibiotics, for example. If we use an antibiotic that kills all the bacteria that there may be there, and we call this a broad spectrum antibiotic, one of the risks of that can be that we can completely depopulate the gut of all bacteria. And that means that that prime real estate, that space in there to be able to set up camp and eat the food that comes along, now could be taken up by much more threatening bacteria. So if you've ever heard of a bacteria called Clostridium difficile, this is a great example of a bacteria that doesn't normally get inside the gut with ease because it can't outcompete the commensals, but once it is there, can be incredibly difficult to remove and causes you, as a larger organism, an awful lot of pathology and issue for it being there. So your immune system, made up of multiple parts and multiple components, has to work together and be able to ascertain who should I be attacking and how hard should I attack them and what is the best strategy to attack them. I showed you three broad different populations of organism: a multicellular worm, a small bacteria, and a fungus. A fungus is a completely different biochemical organism. So we can't hit these with all of the same tricks. We have to hit these with tailored tricks. And that's a big part of what the immune system does. And that's one of the reasons why it's such an incredible system. So I hope that answers the very first question for you. Please continue to look at these. And like I said, if you need information about how to subscribe, please watch the video that shows you how you can do that. And I look forward to seeing you on other talks as we progress through this and increase the complexity of how the immune system works. Until then, thank you very much, and I'll see you soon.